Hello everybody, my name is Eric, and today we're going to be looking at something I thought was pretty funny. So this creator has been hacked and is spreading malware via the fake cheat scam. But what we find amusing here is, let's take a closer look at this video.
Skills at least once. Today, I'll show you how to improve your skills in just a couple of seconds.
So here we first
Let's
of
get
all have a video promoting the
started.
scam, as
Go
we'd
to the website.
expect.
The link is in the description. Download the article.
Okay. Okay. Now here's where it gets really weird. So, first of all, they stole a portion of my video exposing the Overlord rat for 5M, but only a portion. It cuts right to my Proton VPN ad for some reason. I don't know. I'm guessing, I don't know if this was a person or a bot that searches for 5M cheat related content, just wants to use it because they removed the commentary. But then it goes back to my video, which is exposing a different, admittedly, fake cheat as malware. Now, ultimately, both of these are malware. So that hasn't... I don't understand what's going on here. So you can keep going through this video, and you can see it is just my video. We've also got a description where they're trying to put the keywords in, expect, okay, and then there's just some tag stuffing, and YouTube audio library music. So before we try and get to the bottom of this, let's just take a quick break for today's sponsor. This video is sponsored by Ori by Endor Labs. AI coding is taken off. Many teams now generate the majority of the code they ship, even in fields like finance. But that raises a new question. Is security keeping up? It's already a running joke to call any buggy update vibe coded, and the reality behind the joke is real. AI agents regularly push insecure or illogical code, often because they're missing the context to know better. Ori takes a different approach. It isn't just a commit checker bolted on at the end. It works alongside your agents while they code, feeding them security-focused context in real time. Ori is built around the security mistakes that actually happen. Here's an embarrassing one of my own. While working on a video about malware on GitHub, I briefly committed a VirusTotal API key. I got lucky. I caught it and had the key revoked before anyone noticed, but it's a nightmare scenario, and with a more valuable secret, it could have been a disaster. Ori has built-in checks to catch leaked secrets like this before they ever make it into a commit. It has your back on dependencies, too. Ori hooks into your workflow and automatically pulls and analyzes context on every dependency you or your agents bring in, so you can navigate today's software supply chain minefield without walking into a costly compromise. Ori works where you do, inside tools like Cursor, Claude Code, VS Code, and GitHub Copilot, and installs in just a few minutes. The best part? It's completely free for individual developers. No trial, no expiration, no barrier. Head to the link in the description and get started today for free. Now back to the video. So now we're going to head on over to AnyRun and do some analysis on this. Let's take a look. All loaders online, 0% detection. It is a pretty decent looking website, and it claims to have a large quantity of games that it has cheats for, which to me is a massive red flag, but okay. And they even have like this status where it's like, okay, so Apex Legends might be detected right now, but 5M, which is what we want, is undetected. So let's go there and let's see what's going on. So we're going to use, to avoid downloading this on our real computer, we're going to use the submit link option. We'll open this in Chrome. We'll give it plenty of time. And I always like to use the residential proxy because some malware samples do either check your country or check your IP addresses in data centers and anti-sandbox technique. That's really all we should need because now they pretty much built the MITM proxy into it, so we don't really need this setting. And we're not going to use this, but it can be cool, especially in an automated or batched scenario. So we'll go in. Now, initially, we're going to do the setup manually, so we'll open the big window, and there we go. It's just like if it was our VM. Now, I do also want to check out what's going on with that Mac one, but oh, it's real. Okay. I might have to take a look at that another time. That's kind of interesting. But I can tell just from reading that. That one's more obvious. So if we click download there, and so I want to see, do these all do the same thing? Yeah, it just takes us to the same page, which downloads the same version. So all of these supposed cheats are the same file. Okay, so here are the files, and we can see an exe. This looks like an installer, a license.txt, which is just going to be nonsense. Config file. I'll open that just on the off chance. It's like sometimes, no, it's not anything interesting. Sometimes malware vendors do really stupid things, and they'll actually ship their rat config like that. And then we have a bunch of files that are just trying to pad the file size. So let's go back to the analysis now. So recite.exe has run, and it's spawned all of this stuff. It's currently checking our GPU controller to try and detect the sandbox, but we can get around that. Okay, so we just renamed wmic to something else, and the problem goes away. Because now we get a different flag, and we can see a obfuscated PowerShell script has taken off. And now we can go to script tracer, and we can get an idea of what this might actually be doing. Unfortunately, it seems like this script had a backup plan if wmic failed to get the GPUs out, and this one is going to be much harder to fool. So we may have to try other analysis methods. So as we saw, this is in fact an nsys installer. So let's see. Oh, so we've actually got an Electron app in here. So we can drag this out. I'm going to put the app.asr into Claude to take a closer look, but it's surprisingly small. So I'm not entirely clear whether the rootkit application is just a humongous amount of garbage data, which very well could be, or if something else is at play here. I'm going to open it in a hex editor because the compressed version was also much smaller. So that's another red flag for garbage data. So here we have the MZ file, but if we scroll down, yeah, yeah, that does not look like any meaningful code. Now, what we found here, and that's when we're going to pivot back to the sandbox, is, and I was already suspicious, so it's good to see this confirmed. In this resources page, you see this Chinese language pack that is very big. Let's actually load this into our hex editor. But I was already thinking, you know what, this is probably something interesting. And this has high entropy, but that won't stop us. So it also then disables Windows Defender, and then it drops the real payload, which is what we're after. So I'm just going to extract that, and then we're going to get to work. Okay, so I extracted that, and I've just uploaded it to the sandbox, just letting that load back in. The payload is the MIDA protected. So what that means in simple terms is static analysis here is pretty much dead. But that doesn't mean we're done, because we have our cloud-based sandbox, so we can just upload it here and trace out everything it does dynamically. Unfortunately, the malware authors were not joking around with their sandbox detection, so that's not going to work either. Now, I had given up, and in fact, that's why the second part, that's why I happened to decide to tell GPT 5.6, try and unpack this, and to my absolute shock, it did come back with something useful. Alright, so now let's see if this can run on our VM. I'm kind of 50-50. Some of the ways that this thing detected the sandbox shouldn't be an issue on a VM with a real graphics card and different virtualized hardware, but if it has a processor timing check or is deeply checking the EFI, I can't guarantee that it'll work. But let's try it out. So here we go. Recite.exe. We're running the installer, and Defender tries to save us, but we're not going to be saved. Now I've got Procmon going so that we can see exactly what's going to happen. PowerShell keeps getting spawned. The fact that it didn't immediately terminate means we beat the first checks. And it looks like it's spawned sub-processes of web browsers. Let's take a look at what's running. Let's also see if anything's been added to our auto runs. So we've got sysinternals. There's no obvious red flag. Just want to see the last process that ran. We can go to base64 decode. UTF-16 LE. Okay, so we got a Defender exclusion for app data. So let's see then. Has anything new installed itself? That doesn't look quite legit to me. It looks like the final stage does unpack. So let's reduce the noise by getting rid of, oh, and WinHTTP is getting loaded. So maybe we are going to catch some C2 activity. When I see what it did, so I actually kind of made a mistake here. It doesn't go into %app data, which is roaming. It goes into, it creates a new folder in your app data, which it creates a Defender exemption for. So here we go. All right. That's where the malware file goes. It definitely keeps running longer than it did on the sandbox, where it immediately closed. I'm going to try and upload this onto VirusTotal. See, first of all, if anyone else already done it, and if it's detected. Okay, so it's got quite a few detections, and of course, it's the MIDA pact, which does lead to detections. And there's apparently a triage run. Let's see what that's doing. Oh, Microsoft Active. Okay, so it may also have a persistence mechanism that isn't known by auto runs. That's definitely inconclusive. But so that's what it got flagged on. But triage also doesn't see the later stages because this does have pretty good anti-analysis. And it's the MIDA pact, which I honestly thought was going to be the end of this video, but Codex had other plans. So now we're going to go look at the report. So this is the stage map I had Codex make, and I also have a report, and we're going to see if we can find anything else about this. So as we know, this started out with a zip plus some junk files, which then has an nsys installer, which is the only file in there that matters, which installs a piece of Electron malware. The Electron ultimately just exists to decrypt the next stage, which is disguised as a Chinese language pack. That then gives us a Themida-protected PE, which has strong enough anti-VM and anti-analysis that there was no way we were going to get anything. I did try it a couple of ways and it just didn't work. I did not expect any results from that point. I was actually going to give up on going further, but I decided to tell Codex 5.6, you know what, try and unpack it, and somehow it did. I have validated that the C2 and everything in here does work as it says, which is pretty amazing given Themida is probably the strongest commercial hacker. Although I will have to disclaim that by saying that it is a very customizable tool, and the fact that Themida was defeated in this instance may not mean it will always be, because it has hundreds of different VM options, and in this case, it seems that the threat actors didn't virtualize the core pieces of the code, which meant we could just reverse engineer them. They did virtualize a few things, and the packer is virtualized, but what that meant is after tracing out the packer, we end up with something that can just be disassembled. Your mileage may vary. The MIDA comes with a ton of settings. We can see, and you can choose on a function by function basis which parts you want to virtualize. And inevitably, you might think, well, why would they not just virtualize everything? Because that would just be a pain for reverse engineers. And you're right, but it also slows down the code by probably about 1,000 times. And it can also break the code because the VMs are not perfect. And if you ever go on Unknown Cheats, which is probably the best place for packer discussion, both from people talking about how to protect their cheats and anti-cheat protection, Themida is harder to reverse engineer, but it is known sometimes for breaking applications. So maybe this thing pure and simply didn't work when the Stealer code was virtualized. But anyway, I'm happy about it. It also has a string protector, but we were able to break that as well. So Themida was defeated, and then we got a native payload, which was a pretty nice extraction. It wasn't quite clean enough to just execute, but that wasn't the goal anyways. And from here, we could discover a anti-analysis function that used a variety of methods to try and determine if this was a sandbox. It worked pretty well because neither my custom VMs nor any run nor triage were able to get to the final payload. Then does more host discovery. This is sent, and this could be used for server-side validation as well, just so that if a sandbox got through, they could discard the data. And then encrypts and checks if the C2 is valid. And then it sends all of your data out. Now, it's an extensive theft, and we do have a full report, but it's extensive. It steals things that are not even relevant anymore. And this is what the C2 looks like. You can actually check if it's okay. And it has this status that it's live. And we have a decrypted strings list as well. But let's go up and see. So it loads DLLs manually. That could be a Themida feature. Then the built-in C2 is this one, but it uses ether hiding so that if that C2 were to ever go down, it would instead query this contract and then decrypt the key out of that. And it does this using a specific user agent, which is another way for the C2 to give a different response to a browser. It also has sessions, and it sends initial data, every browser data, and an utterly incredible list of wallets. Now, this does make me think, even though we couldn't find any exact matches for malware as a service, this does make me think of malware as a service because Bitcoin, for example, has been worthless since before 2021. Why you would code something to steal Bitcoins, I can't imagine. There are some other ones like Bitcoin Gold. That's not worth anything anymore. Also, the fact that there is a seeming lack of modern cryptocurrencies here. Namecoin? So that makes me wonder about malware as a service, or maybe the thieves here just weren't as into crypto. Also goes for extensions, and then goes through all of your data, even weird stuff like OBS profiles. Maybe that's to get a stream key. And it can also query for tasks, which could lead to additional malware. At the time of recording this, when we tested, there was no additional malware available. Finally, I thought it'd be interesting to try, because this sample will not run on any run. I could not make it, and the Themida patch wasn't good enough to still work, so I couldn't patch out the anti-analysis like I usually would. But I then went to anyone's threat intelligence to see, are there similar payloads? And we found a few. So let's take a look here. Now, these are from April, so it's probably going to be an older version of this. But let's take a look. This one is also Themida protected, but it didn't have as good anti-VM. So we can see, so the file spawns, it uses the debug method to steal all of the browser cookies, uses Polygon to find a new C2, and it sends a bunch of data. And this is encrypted, so we can't make it out, but interesting. And it doesn't seem to have a name here either. This one is more of a kitchen sink. So this Go file, let's see. Oh, wow. So this is like a bundled version that also comes with XMRig. This file link is not live anymore. And I don't see any clear indication of it being spread. I do kind of want to just retry this sample to see in practice how well the ether hiding worked. Like, is this 4-month-old payload still going? That would be interesting to see. So ether hiding immediately gets detected. And does it find a new... Yes, it does get a new C2. But is this C2 any good? It would seem, unfortunately, to our malware, there is no... the C2 was updated from its original, but the newly updated C2 doesn't work. But anyone is still able to detect it because this URL is flagged as malicious, and the ether hiding activity is also a red flag. So very interesting. Interesting stealer. I don't like to compliment malware, but I will say this is pretty well made. Seems like there was effort. The anti-analysis is quite strong. It seems like this threat actor uses Themida across the board, which is one indicator, as is the fact that they look for Bytecoin and Namecoin. So I'm going to call it OG Stealer. That's my name. People can decide if they like that name or not. Please let me know, purely because it's targeting extremely old cryptocurrencies. That's all from me for now. And we'll see if maybe they'll steal this video and use it to promote malware again. And then I'll have to make another video. So it's all from me for now. Bye.